Okay. In this lesson, we're going to go over what is an ampere, what is a volt, what is Ohm's law, what is a watt, how to calculate different electrical values using Ohm's law, discuss different types of electrical circuits. So what is an ampere? The ampere is named after Andre Ampere, who was a scientist who lived until the early 1800s. The ampere is a measurement of the amount of electricity that is flowing through a circuit. We call them amps. Ampere is the correct term. Example, in a water system, it would be comparable to gallons per minute. The letter I, which stands for intensity of current, and the letter A, which stands for ampere, are both used to represent current flow in algebraic formulas. You will see I used in Ohm's law to represent current. The electron flow theory. This theory states that because electrons are negative particles, current flows from the most negative point in the current circuit to the most positive. This is more widely accepted as being correct. The second theory you might see is the conventional current flow theory. This was defined by Benjamin Franklin and is older than the electron flow theory. This theory states that the current flows from the most positive point to the most negative. It's still widely used for various reasons. Some of those reasons being most electronic circuits use the negative terminal as the ground, and when it's used as the ground, the positive terminal is considered to be above ground or hot. It's easier for most people to imagine something flowing down rather than up. For example, most people consider the positive terminal in a car battery to be the hot terminal. Speed of current. To determine speed, we first have to determine what is being measured. As we already know, current is the flow of electrons through a conductive substance. It is estimated that a single electron moves at a rate of about 3 inches per hour at 1 ampere of current flow. Basic electric circuits. First of all, it's important to know that a complete path must exist before current can flow through a circuit. These are often referred to as closed circuit because all the components form a complete loop. Another type of circuit is the short circuit, which has very little or no resistance. It generally occurs when the conductors leading from and back to the power source become connected. A separate current path has been established that bypasses the load. Another type of circuit, one that is often confused with a short circuit, is a grounded circuit. Grounded circuits can cause an excessive amount of current flow. Many circuits contain an extra conductor called the grounding conductor. This is used to help prevent a shock hazard in the event that the ungrounded or hot conductor comes in contact with an outside source. Volts. Voltage is defined as the potential difference between 2 points of a conducting wire carrying a constant current of 1 ampere when the power dissipated between these points is 1 watt. Voltage is also referred to as a potential difference or electromotive force. It is the force that pushes the electrons through a wire and is often referred to as electrical pressure. A volt is the amount of potential necessary to cause 1 coulomb to produce 1 joule of work. So Ohm's law is something really important that you need to know for every single class almost. You need to remember it. An ohm is the unit of resistance to current flow. So resistance is going to be represented as an R, and it's going to be measured in ohms, and it's going to be represented by an omega sign. Without resistance, every circuit would be a short circuit. Without resistance, every circuit would be a short circuit. Anytime current flows through a resistance, heat is produced. So we've already said that electricity loses energy through heat. That is always true. Wattage. Wattage is the measurement of the amount of power that is being used in a circuit. Wattage will be represented by either P for power or W for watts. So here's your power formula. So P is going to stand for power or watts. I is going to stand for current or amps. E stands for volts. R stands for resistance in ohms, and that is the omega sign that you're going to be seeing whenever it's talking about resistance. So power formula, if you're looking for power, you would multiply volts times current or amps. You could do amps squared times resistance, or you could do volts squared over resistance. All of those you could find power. This is Ohm's Law. You need to remember this. You need to write it down every time when you're working through your series circuits. I always wrote it at the top of my page. It's just E over I times R. E stands for voltage, I stands for current, R stands for resistance. And this is a little more advanced pie chart of this. So always remember that current times resistance equals volts. Volts divided by resistance equals current. And volts divided by current equals resistance. And you can use that chart to find this. So whatever information you're given with a certain problem, you can find the answer using this chart in Ohm's Law. Alright, so you have a circuit that has a resistance of 50 ohms and a current flow of 2 amps. What is your voltage? We're going to use Ohm's Law. So what is Ohm's Law? It is E over I times R, which stands for volts over current times resistance. And so now we're going to say E equals I times R, which is going to be our volts equals 2 amps times 50 ohms. Your answer is going to be 100 volts is going to be in that circuit. Alright, so we need to just touch on this. It's easier to write 10 milliohms than 10 million ohms. That is something that we needed to emphasize on. So you need to be familiar with the metric units. So kilo equals 1,000, hecto equals 100, deca 10, base units 1, decis 0.1, centi is 0.01, milli is 0.001. Just wanted to reiterate it one more time that Ohm's Law is very important to what we're doing in DC. So always draw this chart up at the top of your page. That more advanced chart is going to be something you'll probably want to remember too, just because some questions you're not always going to have the information to use just the basic Ohm's Law. But for now, you need to remember E over I times R. That's the most important thing you'll learn in this class.